All right, so talking about standard deviation now. If we look at different measures of variation, trying to see how different our data points are, how spread out they are. We right now have range and we have variance. And remember that range was just how spread out they are in general, high minus low. Variance is how much data points differ from one another, how related to each other, related to the average or the mean, okay? And now we're going to get standard deviation. And I'm just going to say, for my money, in this particular course, because this is considered a liberal math or liberal arts math class, this particular concept is, in my opinion, the most math-y concept that we have. Okay, it's really very math-ish. So, and there's a lot of variable type stuff that goes on and all that. So I apologize a little bit in advance for the notation. You will learn very quickly to read the notation, and I will help you. It's very math-oriented in the notation. So, don't freak out on me, is what I'm going to say. We will work our ways through it together. Standard deviation is a really important stats concept. And so we're going to get there. So basically, let me give you an idea real quickly about it first. Standard deviation is how far data points are spread out from the center. How far data points are spread out from the center. Okay, and that's the center of the data, right? Okay, so, and remember, if we're talking about a normal set of data, for normal data, the mean is in the center, right? And that's a whole concept we've already talked about. But normally the mode's in the middle, the median's in the middle, and the mean's in the middle. So whenever I start talking about standard deviation and how far data points are from the center, for our purposes for statistics, for this stats class, what we're going to do is we are going to assume that again, we're assuming we're working with normal data. There is a whole process, by the way, for, quote, normalizing your data if you don't have normal data. But for our purpose, we will assume that our data points or data sets are normal, okay? Assume that mean is in the center. And we're going to introduce a new notation. It's called X bar. So the X with the bar on top of it will be used for mean. And actually, the X bar is used for mean whenever we're dealing with a sample, but remember, so far in our course, everything we've done has been dealing with samples. We're not dealing with census data on the entire population. We're always dealing with samples. So for our purposes, for our purposes, we are going to be dealing with normal data here and a sample. So we're going to be dealing with X bar for the mean. Okay, so here's an idea. If we say 13.4 is our standard deviation for a set of data, a certain set of data, and it doesn't matter what it is, what set of data it is. If we say that, then what we mean is that most of our data points are within 13.4, whatever the units are we're working with, of the mean. Okay? for one standard deviation. Okay? All right. And I'll give you a graph in a second that shows you what that means. Okay? So, so what we're saying here, again, I'm just trying to get you a concept real quickly, and then we'll get the mathiness in here. What we're saying here is that when we have expected values, remember we want, in a normal data set, we want a lot of our data points to be expected values. Okay? Okay, even if they're a little high or a little low, okay, a little above or a little below our mean, our middle, our center of our data, we expect our values to will fall within 2 standard deviations. Of the mean. Okay, within 2, and that's going to be important for us, 2 standard deviations of the mean. For our purposes in this class, now different classes, different books may look at it a little bit differently, but for our purposes, data points that are more than 2 standard deviations will be outliers. 2 standard deviations away from the mean will be outliers. Okay, and again, remember, one of the points that we're looking for right now is, how do I know if that data point's an outlier? How do I know if I need to get rid of it or if I can use it? Okay, so this is going to be one of the methods that we're going to have for figuring out if data points are indeed expected values, so we can keep them because we expect those, they're okay, or if they need to be tossed because they're an outlier. So that's the whole point of what we're doing here, is trying to figure that stuff out. All right, so here's what this looks like. We've got normal data. So we've got a normal curve. Okay. Right in the middle, in the center of my data, I've got my x bar. Remember, that's my mean. Okay, I'm not always going to write that, but until we get used to this this particular concept of x bar and the notation, I might still write it. But basically, x bar is going to be my mean for my sample. And again, we're working with samples here. We're not working with populations. We're not doing a census, so it's always for the sample for us until we get farther in the course and we go, oh, it's not a sample anymore. Okay, so here's my x bar. It's my mean. It's right in the middle. It should be right in the center so that I've got a reflection on both sides. It's symmetric, okay, because it's a normal curve, right? Okay, and what we're going to do is we're going to do this calculation to find the standard deviation, and however big that is, don't worry about how big it is, we'll talk about it in a second. We're going to say, look, here's one standard deviation, we're going to call it S. Find out wherever that point is. Now, x bar, remember, that's a mean, so it's going to be a number, so maybe my number is 50, I don't know. So if the standard deviation were 10, then one standard deviation above that would be right here at this mark above the mean, and that would be a 60, right? Because 50 plus 10 would be 60. Okay, that's not terrible. All right, so that's one standard deviation. If a data point falls this close to my average, my mean, then we expect it. It's okay. All right, and let me do it again. Here's another standard deviation. I'm trying to make them about the same width here. Okay, so again, if it was 10, if x bar was 50, just going to throw some numbers at it so that it makes sense. If x bar was 50 and my standard deviation was 10, then this spot would be 60. And then what would this spot be? It's 2 standard deviations above the mean. So 50 plus 10 plus 10, right? So that would be 70. Okay, so whatever this was, say this was my test scores, and my average score was a 50, my mean was a 50, then for that particular test, if you were a 60 or 70, again, you're within 2 standard deviations above my average. That's an expected data point. But what if I had a data point way up here that was like a 93? Okay, in this case, he's on the tail. The 93 would be on the tail, right? Okay, and in this case, if I had a 93, he would be more than 2 standard deviations, whatever these guys here are, more than 2 standard deviations above my mean. Boom, you're an outlier. Okay, and so if I was working with that data set, let me put that back up for you. If I was working with this data set and most of my students, the average was a 50, and most of my students were in this area, and then I had this one up here that it was a 93, let me stick that in there. Actually, let me just call him an 80. Okay, I would say, oh, that guy right there, he's an outlier. Maybe something weird's going on. Let me look at that particular test, or let's see if we can throw that one out. Okay. So basically what we're saying is that 2 standard deviations above, you're okay. Right? You're an expected value. These guys are expected values. All right. Well, that's just on the above side. What about on the below side? Same thing, right? So on the below side, let's do the same thing here. What if I was 1 standard deviation below? 50 minus 10, because that was my number I was using. Say this was a 40 over here. That would be, with anything that fell in here, if I had a 48, would be within 1 standard deviation below my average, right? 1 standard deviation below my average. We just said data points more than 2 standard deviations away from the mean will be outliers. We didn't say which direction, right? So we got to go on the bottom side too. So is that 48 an expected value? Yes, because it's within 2 standard deviations. So let's do this one more time. What if it was 2 standard deviations below the mean? In my little example here, that would be a 30, right? Okay, so if somebody made a 35, they're in here in this standard deviation. They are within 2 standard deviations of the average. That's okay. I mean, it's not a lovely score, but that is still an expected value, right? All of these guys in here, I've got 2 standard deviations below. Here I've got 2 standard deviations above. And here I've got my average. Anything that's in there within 2 standard deviations, either above or below, those are expected values. Those are okay, and we're going to keep a hold of those. We are not getting rid of those, okay? But what if I had somebody way down here who made 22? What about that guy or girl? Okay, they're below 2 standard deviations. They're lower than 2 standard deviations below the average, below the mean. So what do we think about that? You're going to have to go, right? We think that you are not an expected value. You're an outlier. So again, on this tail, at the bottom end, also, if you're below 2 standard deviations, below the mean, then you are also an outlier. Okay. All right. So that's kind of the idea of a standard deviation. That's the concept that we're going to be working with. Okay. Sorry, I got too many pages going on here. All right. So what about it? Okay, cool. We've got this standard deviation. Now comes the mathy part, right? So sorry about it in advance. Standard deviation. Let's get the formula for it. And do not freak out when you see this formula. It's okay. We'll work through it and you'll get used to the notation pretty quickly. You'll have to do some homework questions with it and play with it. You cannot just ignore it because you don't like the math. But once you see the process, I think you'll be okay. Standard deviation, SD, or in a lot of books they'll just call it S. Okay? Is this formula. Just write it down. I'll talk you through it in a minute. It's a huge square root. Okay? Inside of the square root, there is a huge fraction. Okay? Just go all the way across. Okay, on the top, there's a sigma sign, capital sigma, like as in the Greek letter. This is a math symbol. We'll talk about it in a second. Parentheses, x, with a subscript, which means down below, x sub I. Instead of an exponent, it's a subscript. Minus x bar. Oh, that's one we know now, mean. Parentheses, squared. So the square is on the parentheses, okay? And then on the bottom of my parentheses is an n minus 1. All right, there's a lot of stuff running around there. So we're going to have to get some little definitions real quick. SD or S means standard deviation. Good deal. Okay, I'm going to assume that everybody watching this video can do square roots and can do squares. So I'm not going to worry about that notation. If you have a problem with that operation or those operations, then go get a refresher real quick. Okay. The x bar, we just said, was mean. Okay. And the x sub I is actually pretty easy. It is your individual data points. Okay, so for instance, if I had 5 data points, I would call them x sub 1, x sub 2, x sub 3, x sub 4, x sub 5. So the I just varies depending on how many data points I have. And it's just a way for me to say, okay, your second data point, well, that's x2. Okay, your third data point, well, that's x sub 3. Okay, it's each individual data point. All right. This capital sigma, that guy, okay, Greek letter. In math, it means sum them all up. Okay. And last but not least is N, which stands for the number of data points. Okay, N is the number of data points. Okay, so if we gathered up, if we were dealing with Babe Ruth's home run series, home run seasons, then he had 22 seasons, so N there would be 22. All right. Okay, so N is just the number. N stands for number of data points. And earlier in the semester, we dealt with the data sample size, right? So, and in those cases, N was the number of people in my data set. Okay, so it's the same N. We've been using it. We have used it before. We have seen it before. Okay, so let's talk about what the heck's going on here. And whenever I look at this formula, I tell people go to the very center, which is inside of the parentheses, and we're going to work our way out. All right, so what's going on inside of those parentheses is, first of all, we're going to have to find the mean. Okay? Find the x bar, find your average. It's not so hard, we can do that. And we've already done that lots of times now, hopefully for the homework. So find your mean. X sub I minus the mean means take each of your individual data points and subtract off the average, the mean. Okay, so what the heck is going on there? What they're trying to do is they're trying to find out if your mean, for instance, was 50 and your data point, my test score, was 55, how far is the data point away from my average? Okay, if the average was 50 and the data point was 55, it would be 55 minus 50, and I would have that the data point was a positive 5 units away. In our case, positive 5 means it's 5 units above. Okay, if the data point was 45, it would be 45 minus 50, and I'd have a negative 5, which tells me that 45 is 5 units below 50. Well, we know that. Okay. So the position here is very important because it tells me if my data point is positive, it's above the average. If the difference here is positive, then my data point is above my average. If the difference here, if the subtraction is negative, then my data point is below my average. Okay, so take each of those differences, each individual data point, subtract the mean, and then square that, okay? And you're going to do this for every data point in your data set. Subtract the mean, square it. Subtract the mean, square it. Subtract the mean, square it. It's very repetitious, and when we do one here in a second, you're going to be like, oh, very repetitious, got it. Okay, once you do that, back it up, then we do the sigma of all of that, right? Well, sigma of all of that, the sigma said sum them all up. So subtract the mean, square it. Subtract the mean, square it. Subtract the mean, square it. Once I've done that, add all of that up and see what you get. Okay, that is the top of the fraction. Okay, n is just the number of data points. So say you had 20 data points, 20 minus 1 would be 19. The bottom is easy to find. Okay, and some books I've noticed have this little correction step and some don't. So normally whenever you're dealing with a sample, you will see this n minus 1. And basically it's just a little correction step that helps the approximation for the standard deviation be closer. Okay. All right. So do the top, do the bottom, then divide. We're still working inside, right? Don't worry about that square root yet. Do the top, do the bottom, divide, whatever that is, and then whatever you get at the very, 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 very end, then we're going to square root it. Okay? So keep that in mind. And I'm going to walk you through those steps as we go. Don't worry. We'll see some stuff. All right. Let me find... Oh. Let's do a really small data set because these numbers get crazy fast. All right. Let's say our newest data set is 51, 53, and 64. It's just 3 data points. Trust me, we don't do very large data points like this by hand because this gets really big really fast. Okay, so hold your thought about anything about getting too big too fast. Okay. 3 data points will be enough here. Okay, first step, find your mean. Okay, well to find your mean, what are you going to do? 51 plus 53 plus 64, divide by, how many am I dividing by? There are 3 data points there. Oops, which means my n is 3. Oh, that's right, we saw the n there also. Okay, so X bar is, I did this calculation earlier, I think it's 57.4. Please check me if that's not right, then let me know. Alright, so my average for this little 3-point data set is 57.4. Okay, first step. That's my first step. Second step, find the deviations from the mean. From the mean. For each data point. Okay, what the heck does that mean, Dr. Webster? That means you're doing this right here, x sub I minus x bar. Okay, so I have 3 data points. The first one is 51. So I'm going to go, first data point is 51 minus, what was my x bar? 57.4. Well, when you subtract that out, you get, that's a negative 6.4. Everybody okay with that? So how far is 51 away from the average? Negative. It's 6.4 units below the average because it's negative. Negative means below. Let me do that. I don't know why this guy's not writing below the average. Okay. Next data point is 53. Minus the average is 57.4. So use your data point minus your x bar. And once I have my mean, it's always the same thing, right? Because it's the same 3 data points. Okay, whenever I subtract that, I get negative 4.4. What does that mean for me? Okay, I can interpret that to be 53 is 4.4 units below the x bar, below the average. Okay. Well, the average is in the center of the data, so that means there's only 3 data points. 2 of them are below. That means the next one better be above, right? Because it's got to average out to be 57.4. And sure enough, when I do the third data point, it's 64. Third data point is 64, x sub I, minus x bar is 57.4. That's going to be a positive, right? So, because 64 is bigger. So now I've got 6.6, and it's positive. And because it's positive, we don't have to write the positive, but we look at that. That means it's above the x bar. Okay. So it's got to balance out. If you have 1 or 2 that are below, you've got to have 1 or 2 above. That's just the way it works. All right. So there's my second step. These guys right here are deviations from the mean. How far, so deviations from the mean. It means how far is each data point away from the average. That's what we mean there. Okay, so that's step number 2. All right. Step number 3. Take the x sub I minus the x bar, which is all these 3 things I just did, and square them. That's your next step. Square them. All right. So here's an important piece. What happens whenever you square a negative number? Negative times a negative is what? In my head I hear you saying, a negative times a negative is a positive. All right, so my first deviation from the mean was negative 6.4, and when I square that, negative times a negative is a positive, I get 40.96. Okay. Next one. Negative 4.4. Now notice, I don't do this calculation over again. I already did it. I'm just pulling from here. So once I have that, I'm just going to stick it there. And I'm going to show you in a second. I usually will do a table, and I think that helps people to keep the steps straight. So, but for right now, I'm just walking you through what the math is. Negative 4.4 squared, well, whenever I do that, I think I get 19.36. You can punch it on a calculator. Pause the video if you want to, whatever, and make sure that you agree. Negative times a negative is a positive, and 4.4 times 4.4 is 19.36. Okay, and the third one was a positive 6.6. And again, when I do a positive times a positive, I get a positive again. So a positive 6.6 times 6.6, I've got 43.56. Okay. So, and you will do that for every data point that you have. First you subtract the mean, then you square it. Subtract the mean, then square the thing, whatever your difference was. Okay, so this step is square the deviations from the mean. Okay, that's what we were doing there. All right, square the deviations. Now, let me go back to my thing. This is what we've done. We found our average, we found the differences, we squared them. The next thing, remember we were just working on the top, is sum up all of that. So we did this difference thing, we squared it, we're going to sum up all of that. So add all of those up. So step 4 is sum up all of what we just did. Well, we already did, oops, put the bar on the wrong spot. We already did all that, right? This stuff right here is this stuff right here. So I'm just going to add all of these up. 40.96 plus 19.36 plus 43.56. Okay, and when I add all of that up, I've got 103.88. I hope that that's right. So sum all the squares. That's what that means. Okay, that's what we're doing there. Okay, so now we're done with the top. We did everything on the top of this fraction. What's on the bottom is just n minus 1, so that's pretty easy, so don't stress out about that. So we need to do n minus 1. Well, we know that one. There were 3 data points. 3 minus 1 is 2. Woo! This is your denominator. Okay. So we're almost there. So now we just need to divide these two out. 6. So do this stuff that's all on the top. I won't always rewrite this. I'm just doing it the first time we're messing with it so you can see what's going on. All of this stuff on the top was this 103.88, and the n minus 1 on the bottom, that's my denominator, that's the 2. So when I divide that out, I think I get 51.94. Okay. This step is divide. That's all we're doing. So 103.8 divided by 2. We're almost there. Okay, again, let's look at our formula. We did the top. We did the bottom. We divided. So we're done with everything on the inside of the bracket there. And the bracket says square root it. Okay, and I'm just going to make a little observation. When we squared these, it made everything positive, and it made them all, normally it's going to make them all bigger, right? Not always, but normally it makes everything bigger. So because we squared it, and that kind of messed with stuff that's going on, we do this square root to kind of undo the operation of squaring that we already did. So we made things big, and now when we square root, it's going to bring it back small again, right? And that's normally what happens. Normally your squaring makes things bigger, and then your square root makes it smaller. So basically what we're looking at here is how far all your data points are from the mean, and we're looking at them as a collection, right? We want to talk about the entire data set. So that's why we have to do that to every single data point. All right, last step. Square root the whole thing. S equals square root that whole thing. Okay, well, we had 51.94, right? So we're just going to square root 50, sorry, I can't write tonight. 51.94. And when I look at that, I think, oh, the closest perfect square to that is 49. And the square root of 49 was 7. So this is all going to be slightly bigger than 7. And in fact, whenever I do that calculation, if you do that calculation on your calculator, hopefully you get around 7.2. All right. So those are the basic steps walking you through that formula. I know it's a little bit convoluted. You'll get used to it pretty quickly. What does this all mean? This becomes the next question. Well, what it means is, let me give you a picture. Okay, if I'm looking at this data set, and my average is right here in the middle, and that's my X bar, which was the 57.4, right? Whenever I go to figure out one standard deviation, one standard deviation here is 7.2 units. S equals 7.2. And then this next standard deviation is 7.2 units, right? And I would look for 2 above. Anything above that is an outlier. And I also look for 2 below. 7.2 units. Oh my goodness, sorry, that's not even. 7.2 units. I tell everybody I'm not an artist, sorry. Okay, so as you look at that, you see each of those standard deviations that we looked at earlier, that we saw earlier, oh, each one of those is 7.2 units wide, right? Okay, so for our purposes, here's a better picture. Here we go. So when we were doing this a little bit ago, we had this X bar as we do a standard deviation above. In that scenario, I was just throwing out numbers. I said it was 10. But for this data set that we're doing, the 51, the 53, and the 64, their standard deviation for that data set would be 7.2. Okay, so you're finding how much is here, how much is here, how much is here, how much is here. So you just keep on doing that over and over and over again. And anything that falls outside of that, well, wow, those guys are all outliers. Yeah, that's the whole idea. So our whole point here is trying to find that, right? Trying to find the outliers. Okay. I have a couple of data sets that you can practice on. I am not going to walk through all of these things, but I will give you a couple of data sets that you can practice on. Let me see, maybe I'll do one of the data sets. Oh, they're both pretty big. I don't want to do that much, but I'll give you some answers, okay? So let me give you the data sets, and then you can, I'll give you what I think is going on, and you can work on them on your own and see if you come up with the same stuff that I do, just as practice. So the first data set I have is 47, 82, 30, 20, 76, 21, 89, 73, and 38. Okay, so it's kind of a big data set. It's not huge. 1, 2, 3, 4, 5, 6, 7, 8, 9. By the way, that tells me my n equals 9. Okay, so there's only 9 data points here, but I'm going to tell you it'll take you a little bit of time to do the computations here. Okay, I'm going to do real quickly for you the average. If you add all these up and divide by 9, that'll give me the mean. 38 all divided by 9 gives me 52.9. So do the arithmetic here, make sure, but I'm going to tell you that I think the X bar is 52.9. So you've got the data set right there. I gave you your average, give you a little bit of data, a little bit of information so you can work on it. And I'm going to show you, I usually will give on a test you the ability to work with a table, because I think that sometimes the table helps people kind of organize stuff. So I just break it down into steps. So your first step is your x sub I minus the x bar, right? So that's the first step with your individual data point minus the x bar. So I just make that one column for itself. And then once you have that, if you'll go right next to each other, right next to that, x sub I minus x bar squared. Okay, that looks crazy, but you get the point. Okay, x sub I minus x bar squared. So you don't have to redo the x sub I minus the x bar, right? Just take whatever you got for your first column here and square that. So for instance, I'm just going to do one of these. Your first data point is 47. 47 minus 52.9 would be your x sub I minus your x bar. I get for that's negative 5.9. That's my deviation between the data point and the average. Okay, So I don't redo it. I just come over here and say, what's negative 5.9 squared? Because I already did this math. I don't need to redo that. And when I square that, I get 34.81. Okay. So you would do that for every one of them. The next one's 82 minus 52.9. Figure out what that is. And then take that guy and square it. And what do you get? Okay. So you really just need those two columns to kind of figure out what's going on with the deviations from the mean. And then somewhere over here, what we'll do is we'll add together all of that. Okay, and you don't have to keep a running total. You can just do one giant sum, add them together, and then you can work through the rest of the process. So it's this sum, x sub I minus x bar squared, whatever you got there. Okay, you'll put here, divided by, well, this one's actually pretty easy because we divide by n minus 1. Well, 9 minus 1, well, we know that's going to be an 8, right? So figure out what that stuff is. Do all of this, figure out your sum, divide by 8, okay? I'm going to tell you what I've got here. My number looks like, let me get a new sheet of paper. Okay, I've got a lot of stuff going here, and then whenever I get to this point over here, I've got my summation here for me. So you check it out. My sum of all my x sub i's minus x bars squared. I think, so make sure your matches mine, because I could have made a mistake when I did this in my office. I think this is 5,968.89. That's a really big number. So it's really easy for me to make little mistakes, and it's really easy for you to make little mistakes. So make sure you've done it, okay? So I think that's what the top of my fraction is. Okay, so now I have 5,968.89 divide by 8, because 9 minus 1 is 8. I think that I'm going to take the square root so that I don't forget it, right? Okay, the whole formula has a square root on the outside. I think that divide first, square root of 746.111 is approximately 27.32. Okay, but don't take my word for it. You have got to do these steps. You have got to get used to it. It's like muscle memory. Okay, I take the data point, I subtract the average, I get an answer. I take that answer, I square it, I get another answer. I add all of these answers up. I actually on mine do like this, and I put a total down here. So the total of all of this stuff, and I just stick it right there. Okay, so but you have got to do these steps for yourself. You can't go, oh, I get what she's doing, because if you do that, then I promise you on a test it's going to get bogged down because you're not going to have that muscle memory developed. So you have to do it, and then you have to do all the rest of the steps so that you know for a fact, yes, I can do this, I can get that. I figured out where she got that 5,968.89, right? That was this number right here. Okay, I figured out where Dr. Webster got that, and now I've done the rest of this stuff. You have to do the division step first. If you take the square root of this guy right here and then divide, you are not going to get the right answer. Okay, so you have to do the division step first, and then you have to take the square root. And normally when you do, like after you do the division and the square root, it's normally going to be some weird, really long decimal. So again, kind of think about how many decimals were in my original data. Well, these guys were all whole numbers, right? No decimals. So you can round here to 1 or 2 decimal places. Okay, and you'll be fine. Do not round to whole numbers. That's not okay. All right, so there's one of my data sets that I wanted to give you. And then I have another data set. And again, I'm not going to do all of this. I'm just going to tell you the data set and let you work with it. And I'll tell you what I think it should be so you can check yourself so that you get practice. Because this stuff right here, You just got to practice with it, guys. You've just got to, okay? If you don't practice with it, then you are likely to get stuck on it and be like, oh, I can't do this. And this is a big problem on the test. Okay, so my data set is 14, 6, 11, 10, 12, 10, 7, 12, and 13. 1, 2, 3, 4, 5, 6, 7, 8, 9. Again, my n is 9. The n is not always 9, but for these, I guess I just picked ones with 9 in them. Okay. All right. I think that x bar here, the mean, is 10.6. You better check it and make sure you know where the heck that number came from. Okay. And then I think that the sum of all the x sub i's minus the x bars squared, so you got to do your table or do your math, however you're going to do it. I think that that sum is 56.24. I think when you do the division step, my answer is 7.03. And I think my final answer here, my standard deviation, is 2.65. Okay. And I told you, this is like the most mathy concept, I think, in the stuff. So don't get stressed out just because there's a lot of math all of a sudden. It is the most mathiest topic that you're going to have, and I think you're going to be okay. Oh, I have one more data set, and again, if you don't want to do all of them, you don't have to. But I see that I have it, and I'm going to give it to you real quickly before I'm done with this video. So my data set is, and I really want to give this because it's not 9 data points, so yay. It's 361, 121, 36, 4, 196, and 400. Okay, so the n here, 1, 2, 3, 4, 5, 6 is 6. Okay. I think that, I didn't write down my x bar. Ooh, I didn't write down my x bar. Hang on just a second, let me see. Dang it. Okay, so I can't give it to you because I don't have it. Well, you can just do it. There you go, if you want to. If you want an extra practice problem, I don't have the rest of this stuff because I stopped writing apparently, so I don't have it. But if you use these as your 6 data points, and you know that there's 6 of them, you can find your own x bar. So you can do that, and then find the rest of them. Okay, so the sum and the division and your S equals. Okay, so you can do all of that for yourself, and there's a data set. There you go. So I don't know what that is. I'm sorry I didn't write them down. That stinks. All right. So that should get you going on standard deviation. There will be homework on it. And if you have questions, feel free to send me an email. Again, I know this is really kind of mathy. The notation, you get used to it. I promise you'll get used to it. You just have to play with it. You've got to do it or you won't get that muscle memory. All right, good luck with it. Let me look real quick. I'm sorry. Make sure I hit everything in my notes. I just don't want to mess you guys up. Yeah, I think that's it. There, in the book, there are some alternate notation things, but this is what I'm sticking with, so I'm not going to use any of those alternates, so don't you worry about it. All right. If you need something, let me know. Otherwise, have a good week. Thanks.